course, the many large-scale projects funded by NIH, DARPA, and others that he's directed over the years, much to our great benefit around here. And of course, was a huge influence on the early days of this program, continuing right up to the present, of course. So he's going to talk about his latest big thing, which is the tranSMART platform, and try to explain to us what they're doing and how they're going about doing it. Okay.
Well, thanks, Dan. Here, I'll turn this thing on now. Yeah, it's on. Good. I'm sure it's a small room. You might say there were two reasons why I got into tranSMART in the first place. And neither one of them, I really didn't want to. One was kind of a trick. I mean, I was invited by these White House guys down to a bar, and they started buying strong drinks and telling me how they wanted me to go to a tranSMART meeting the next day, which I agreed to do. And the other one, in all seriousness, and the other one was that Jill had said that I needed to do something big to follow on from the NCIBI, and this was a huge problem actually, because the NIH, and I think many of you know, many of you probably don't. I worked at the NIH for 3 years, a day a week. I'd fly in on a Thursday night, and I had an office over there in Building 1, at the director's office, and they were trying to snare me into overseeing informatics and information technology for the entire NIH, and I was kind of doing that for 3 years. And, we had this big problem that, we needed to create a vision that would keep, on the extramural side, we needed to create a vision that would leverage and grow and acknowledge this coming big data thing. Actually, I was asked, finally they asked me, the director's office asked me to write a report, which led to something called there was a process that I think is out there now, advisory council to the director. We had, I wrote a thing up to get this thing called the advisory council to the director that was about data and information and what we were going to do. That was my report that started that. So I had created this huge briefing, and the only thing that the director and Dr. Tabik had any interest in whatsoever was big data. They said big, I had 85 PowerPoints. Tabik told me, cut it down to 5 PowerPoints, and every one of them ought to be about big data. That's all we care about. Well, that's great. So now we have big data to knowledge. That's coming along. It's a little slowly. You have 3 years ago, you come up with the idea. Eventually, it kind of meanders through the system. And, and I've got a slide on this. It's a huge challenge. As the data and information gets bigger, the funding to take care of it gets smaller. This is a big problem. And and it's not, this is why it's a good introduction for this talk. Because the question is, what are you going to do? And so what is tranSMART? Question mark. What is the tranSMART Foundation, and why are these important to integrative informatics? So what are the opportunities, the challenges, and the problems? And then how does tranSMART contribute to the solutions? What is it? The basics. What's the roadmap that we've established? What's the community look like? And what's the foundation that we created to support the community, which is we got the 3 C's, so it's in politics. You got the code, you got the community, you got the code, and you got the content, the 3 C's in tranSMART. Okay. And well, this is I saw a few slides from Mike Snyder. I think part of the reason that I wanted to mention this is in the opportunities section. But they are challenges. And this is a little bit of an unabashed advertisement that George Mias, who's the guy who did the Snyder Room, is coming back for a second visit to looking at the faculty here on the 23rd. There's a chalk talk, 23rd and 24th. Check it out. But, this is kind of the holy grail stuff. Here's the opportunity. Health is a process of this is a hopeful slide. I mean, it could be this, right? I mean, but it is a product. If you think about the genome and the ohms and all the stuff in our environment, genes by environment is phenotype. Here's another way to look at it. You could put a zebrafish in there if you wanted to. It doesn't have to be a human. And we have all these high throughput measurements that we're creating and all the models. And, a lot of it's at the cellular level. And then you got to figure out what happens at the various tissues and so on. It's this big hierarchy. The hierarchy's been around forever. You know, it really, the ecologists discovered it, you know, probably first in science in the 50s, and then the brain scientists worked with it a lot and really made something out of it later. By the time I got into the hierarchy for my job talk was in the mid 90s, you know, I presented a slide like this and, you know, I got the job, but I think a lot of people thought I was crazy. But this is really what's going on now. And of course, there's just like we have, it's kind of like you have transdisciplinarity. I mean, you know, the microbiome and all these things are, you know, kind of how they fit into the hierarchy is interesting. And so, you know, it could be, and this is one of the challenges we have with integrative informatics is, you know, trying to figure out when we can bring the data together all the way up the line to describe the phenotype or maybe to describe populations. One of the things that's a passion of mine, I want to come back next term if you'll invite me and give a science talk. This is not a science talk. This is about cyber infrastructure. This is about, you know, what we're building to support and enable science. I do have a science talk. It's in the area of pharmacogenomics. And, you know, the dream is that you can understand pulling from various places like electronic health records and maybe pharmacy records and something about the omes and the genome, and you know, you can actually figure out what drugs are good to take, what drugs are not good to take, and so on. There's a huge problem that I've discovered over the years, you know, not only in the psychiatric space, but I work, but more broadly, this adverse drug reactions, adverse events, this kind of thing. It's a multi-billion-dollar problem. People die. There's a lot of mistakes. And, you know, so this stuff can be, you know, following through on all this promise of this hierarchy and ohms and high throughput and bringing together the genotype and the phenotype could really help not only health in medicine, but more broadly into biology and in life. You've seen this slide, so we don't have to go over it other than to say it's another way to, it's a challenge, the data integration. Now this is a classic. Some of you guys like Jeff Cowell and Jim Mazatix and others that work in this world, Kayvon's starting to get into this in a big way here now. Marcy knows a lot about this. You know, the challenge is the old data, those are little silos over there, you know, the so-called data silos. So, you know, when you go from the science to the infrastructure and they become data silos, you want to bring them together in an analytic frame. You need, you know, you need a catalog of what you got. You need the infrastructure. You need the middleware. You know, all this all up and down the stack. So there's a hierarchy in the infrastructure, just as there is a hierarchy in the science. And, you know, the problem is that one database doesn't, you know, they say talk to another one. I mean, you know, it's kind of sloppy language. But there's the interoperability and the ability to bring data together and to aggregate that data and to properly understand how to dimensionalize it so you could even ask questions against it. And what's the statistical logic of that? And could you infer anything that would be meaningful and all this kind of stuff? It's a huge problem. It's beyond the infrastructure, but the infrastructure alone is daunting. And this, you know, and by the way, one's infrastructure in one place, like even places that you might think would be similar, like the University of Michigan, we have EPIC, we have Eclipsys. Johns Hopkins, we have EPIC, we have Eclipsys, you know, and all these other, we have a cancer center, they have a cancer center. I'm here to tell you, since I know both places well, don't think they're the same by any stretch of the imagination. So how could you even get a share data between institutions that are the same, let alone more broadly, or let alone across the U.S. to Europe, and don't forget about China and everything else. This is an international problem right now. You know, and let's not forget about the FDA. You know, this is a slide that was made up to, you know, for folks in the pharma industry. You know, they have to work with the regulatory agencies and regulatory science. But, you know, we do too. If we do drug discovery and we start testing it into clinical trials, there's standard operating procedures. You know, and we have to, our data environments, information analytics, and all the rest have to be compliant with ISO and all the rest of the stuff. This is a huge challenge right here. Curation. You know, garbage in, garbage out. It's as simple as that. And, you know, some groups pay a lot of attention to this, you know. Well, the NCBI and the EBI, you know, our reference information bases across the world for informatics pays pretty good attention to this. Companies that care about their data and what's getting out the other end, which would be pharma and biotech and others. I mean, just dealing in the biological sector now, deal with this. I think it's, you know, I'd be curious, Bob, to hear what you think. We don't do a really good job at curation, and nobody really pays for it much. And, you know, we've disconnected the librarians who curate things, that's what they love to do and they're good at it, from the enterprise. That might be an opportunity if we could get them back in. And, you know, we're moving along that line here at the University of Michigan. You should know that, right? We got Elaine Westbrooks down on campus. We've got, you know, a lot of activity in the library to figure out how we manage our data and information going forward. For the knowledge age, things have to be properly curated. You know, and then there's these little, there's acronyms. You know, I remember I used to go to meetings and I had so many acronyms. Years when I worked at the DOD, that was the worst. But, you know, really, this health IT has as many acronyms. When you say, Jeff, as the DOD. So ETL, extract, transfer, and load. There's a lot of little acronyms. I'm going to avoid them, but they're there. Curation scales linearly with the number of people who are curate. You know, there's a big experiment that was done in the Library of Medicine on that with PubMed, you know. I don't know how many people have been down in the basement of the Library of Medicine, you know, and seen all those people at PubMed just working away like beavers. I mean, that was the old days. Now they work at home more. But I'll never forget when I first saw that. It doesn't scale very well, but it can be computer assisted. You know, we can stamp records with, you know, metadata, and, you know, you don't have to hand curate everything. What you need is to create data standards and metadata, you know, that can be, you know, if you've got data flowing off these machines, you know, just as we're doing in the lab, and you know this. I mean, there's a lot of data in the records that could provide the metadata base. You don't have to do it all, but you have to have somebody in there managing your libraries. It doesn't manage itself. So we have a health system data warehouse, we have research data warehouses, we've got lots of data warehouses around here for the billing, compliance, all this kind of stuff. Those all have to be curated. They don't curate themselves. And it's a growing problem. And we will fall behind in the research if we don't do some of the curation necessary to bring the data together, aggregate it, and analyze it. And then it's semantic consistency, whether it's common data elements, whether it's, you know, adherence to some, ontologies. You know, Marcy and Alla are here. We got Oliver. We got some ontologists around. You know, moving from data to information often involves metadata and some kinds of ontologies. And certainly if you want to, you know, encode going backwards, you know, whether it's for encoding prior knowledge or, organizing a knowledge base, which is really the holy grail. I mean, you know, it's knowledge that we're after creating here. It's knowledge that we want to disseminate. You know, you need to encode the knowledge into something. Largely, that's an ontological scheme that has some semantic consistency. And you know, these sound just like words, and they are. But if you want systems to work, you got to have them. RDF and all this kind of stuff are some of the infrastructures that we use to allow for this. Medra and all these. Sarah's working with a lot of these. There's a lot of government systems, big systems that we have to work with and interoperate with that have standard ontological nomenclature systems that we have to adhere to. That's just the price of doing business. You know, everybody wants this. You've got your bioinformatics and your tissue banking. Everybody knows that we have a tissue bank set up going here. How many tissue banks do we have in the health system? Anybody want to guess? Huh? Probably well over 100. I mean, when I heard earlier estimates of 380 freezers that they wanted to put in the building 38, I mean, you know, it was something like that. You know, we have 4 big ones. We have a 3-year. This is overseen by the Office of Research. In the medical school. We have a 3-year, $5 million per year biorepository program here with 4 pilots, including Gonzalo's pilot on the DNA libraries. the head and neck pilot and others. Then once we get the structure, we do have a limb system and so on and so forth. Everybody's got to have a biorepository. Just to make matters better or worse, the campus has a biorepository too. They're not using ours. They've got another one for various reasons. So even here, there's a lot of stovepiping. But the idea, the dream that the researchers have on the clinical side is, you have tissues that are in a biorepository. Those tissues are linked to patients. So you have patient identifying numbers, patient identifier numbers. Goes down to Bob's core. Next-gen sequencing is done. Flips over to Jim, does the bioinformatics. Maybe Chuck Barant and Hala and others get involved in metabolomics. Then you want to pull down the electronic health record components. Maybe you care about what drugs they take, whether they sleep at night or not, whatever. Do they smoke? It's all got to be brought together. And then the challenge is illustrated in the box. It's called stratifying the phenotype. If everybody's the average, so personalized medicine is everybody's its own little box. The way we've been doing things is everybody's in the same box. Probably what we want to do is run cluster analysis and create several boxes in the middle somewhere. So there's statistics there. And everybody wants that. You'll notice these little TransMART arrows popping up. Well, whatever. So more about that in a few minutes. So then there's another set of problems, even bigger problems. This comes from a government report that Gary Neal, who was coming in and out of this place, who used to be the head of J&J Science and Technology. And then certain fields, and June and I were talking about this the other day, neuroscience, neuropsychiatric work, whatever, no drugs in the pipeline. All this depression, schizophrenia, autism, bipolar disease, whatever, no drugs in the pipeline. Big problem. Why? They fail. Why? Cardiovascular is a bigger market. Diabetes is a bigger market. Obesity is a bigger market. So the pipelines are drying up. Problem. Alzheimer's disease, $1 trillion burden of health, 2050. No drugs in the pipeline. National problems. So, and then this other thing in the red, this is real. This is scary. This is the truth. Lots of data. I'm focusing on clinical research studies now. Not in Science, Nature, and Cell. Over half can't reproduce it in big labs. So, if you're pulling down data from the literature, how do you know if it's any good or not? That's a big problem. There's been a lot of high-level meetings in government on that one. And there's been a lot of studies, where J&J would have 250 guys in an NLP, a GLP lab, and they'd try to reproduce these studies. They couldn't do it. So there's this kind of Collins, this quote there. It's fantastic. We can do these ohms. We can do all this stuff. We can create the new world of science, but, can we? It's a very interesting dilemma right now. Are we going to be able to create the enabling technologies to do this? Or are we going to go into a dark age period where there's a lot of promise out there and we'll get one-offs? I threw this in at the last minute just to show how things are changing. This is in my introduction. I had to give a talk at the National Science Foundation on the future of Cyberinfrastructure. I must have been an idiot. I mean, they invented the term. I was the keynote speaker. So I was, night before, like I always do, I was trying to come up with a talk, and I was just thinking about a timeline. Well, this is important because, if you look, the driving problems in the NCBCs, and we can just, at that point, we thought we could create, maybe 15 or 20, we did 8 of them, NCBCs, they're big science, big labs. Don Lindbergh, the library medicine director, he said, look, we can't put it all in NCBI. It doesn't scale. So why don't we build 20 NCBIs and keep them going? Build a network of NCBIs. That was the plan in a nutshell. NIH didn't get close to it. CTSA, same thing. I've got a slide on. We got 60 CTSAs. We'll create informatics infrastructure everywhere. It will scale. It bombed. And now you see what's happening. Now you got sequester and all this other things. Clouds came up. Nobody knew what that was. But open access, sharing, lots of about that now. But the bottom line is the key word on this slide is public-private partnership. We realized that the government could not fund all of this. There was no way, and that we couldn't create groups big enough at one place to do it. Well, and then a lot of people tried. On the data side, you know, there was something else that happened. There were a lot of groups that kind of sprung up for various reasons, like the Multiple Myeloma Research Foundation. I don't know how many people know about that place. It is fascinating. You should all log on and check. The story is fascinating. The lady, kind of a middle-aged rising star in pharma, she was diagnosed with multiple myeloma like 22 years ago. She was told she had 6 months to live. Get ready, you're never going to see your kid graduate from high school. She's still around. She's got a network. Anybody with multiple myeloma logs into the network. It's like patients like me. It's a community, you know. People who have the disease come together, social networks, different concept. Lots of that happening right now. Disintermediating the academic health centers from the process to a large degree. You know, lots happening in this space that we need to be aware of. And then the Creative Commons and that kind of thing, and the follow-ons that John Wilbanks has done. You know, portable IRBs, simplified consents, that kind of thing, as opposed to like endless reams of paperwork. You know, put these things in a you know, container and make them scale. It has to do with the scaling problem here. Okay, and then there's this other thing. This was a classic. How many people know about this one? The Global Consortium to Share Data, Genomics, and did you know about this when it was announced, Bob? No, neither did Ardeen, either did Aura, even though the University of Michigan signed it. They called me wanting to know what it was about. Frank was on some of those messages. Well, you know, it got Mike Banky and Gonzalo got going on it, and then they went to their dean, and then their dean went to Mary Sue, and she told it, and she forgot to tell the health system. More about the open science bionimbus later. We're part of that. All right, this is a very important slide. This was created largely by Zach Kahane, who was at Harvard. He's going to come here and speak to us soon. He's a good friend. You know, those little stacks were inspired by the little stacks that you saw in the earlier diagram. I mean, we talked about that. You know, he changed it, like, you know, that exposome that was in the Snyder slide, I never had that. We got to have it over on the side. So the idea of an information commons with two parts. You got a kind of a biomolecular, I don't know if this is the one or not. On this side, you got the bioinformatics and the high throughput and the molecular biomarker stuff. This is the bioinformatics side of the equation over here. Okay, I got it. Big beer berry. It's this one. Let me see. Yeah, that's the molecular side of the equation. All right. There is the clinical research, clinical discovery side, the EHR pieces and all that, the phenotypic representations, both feeding into the knowledge network, tied together by ontologies and mapping, overseen by the compliance office. This is a very, very, Marcy, you must see this a lot. I mean, this is really an important vision here. Very important vision. Okay, that started floating around a few years ago. And then, okay, well, then tranSMART. We'll get more into the details in a minute. You know, have all these clinical and biomarker, biomolecular, up and down the hierarchy into some kind of framework, and then you get results. So, all right, so let's get into what this is. Well, you know, simplistically, you know, and this used to drive me crazy in the early phone calls with J&J, and I'll get to the history in a second. This might be out of order a little bit. You know, they called it a data warehouse. Well, hello. It was hardly that, but, you know, there is a data warehouse component, and Frank and others who are leaders in this know what those diagrams look like. And then there's some kind of middle layer there, which is the middleware. And then you have the applications that you can run on top of the middleware that drives in. It's kind of a three-layer deal, okay? There's a data layer, there's a platform middleware layer, and there's an applications layer. The idea is to plug and play. The platform evolves under control. The data, you do your best. You can have separate instances. The applications, the big key is to try to get data from one application to go into the other application. You don't run bioinformatics like a phone. You know, you don't launch an app, go in, go back, another amp. You'd like to have them kind of flow through, okay? Here's another way to look at it, okay? We have a core, and, it's all data and information kind of in the middle, There is a cloud piece, more about this in a minute, and then services, and then plugins. We're going to get into the details on the architecture and the timelines and all. So this is just conceptual right here. But it's what we do. Okay, and then I2B2, you should mention that. What's that? Anybody, few people know what that is. That hit big. Few, not many. Integrating bench and bedside, I2B2. That was Harvard. They had a National Biomedical Computing Center, and Zach Kahani and Sean Murphy were the brains there, working with John Glasser, actually at Partners. He was the CIO then. He was very supportive, and Suzanne Churchill, who was really the one that ran the show. And, great team, and they come up with this vision. We can we can build this. It was the original tranSMART in a lot of ways. It really was. So what happened? What happened, and it kind of had a left-hand side, which is the data management side, and the right-hand side, which is the analytics side. And if you look at this, and this is data that actually is, we embedded I2B2 within tranSMART. It was one of the key early features. It was open code. You can take it, put it in. So they stuck it in there. And but then we made it to work with the molecules. Zach and company could never get the molecular side to work with it. They were great at pulling down stuff from the EHR. They were great at organizing stuff from the EHR. They were great at looking at the analysis of things within the EHR. They could never get the molecular piece in. They still can't. So we took it, we embedded it in. Who's we? Well, in the early days, we was the Johnson & Johnson Corp. So the story of Johnson & Johnson Corp was that they had 125 data silos across CentCore R&D research. So head of science pulled in Eric Paraskos, who was the CIO of CentCore at that time, and said, nobody can, everybody thinks they own their data. Everybody is keeping their data private. We're a company. We're developing drugs and compounds. You are the CIO. Fix it. So what any smart CIO did, he outsourced it. I mean, he hired a contract. He had a good idea. He said, let's take from the open source. Let's take from the NCBCs and the NIH. Let's take I2B2 and fix it. And let's put it on a cloud, which was unheard of. What the hell's a cloud in 2007? This was his little way of disintermediating, all due respect to you, Jeff, and your team, the IT force at J&J who didn't get it and didn't want to do it. Outsource the IT to the cloud. And then work with the cloud company to make sure it was safe and secure and you could put your proprietary data on the cloud. And then there's this other thing that came up, and this was demonstrated in Europe. Really, it was between, I think, GSK and J&J in the early days, and there's several examples of this now, the so-called pre-competitive data sharing. The old school, if you're working on an asthma compound and you tried A, B, C, or D, or you're working on the one that we're looking at the FDA is cardiac TKI, cardiotoxicity. So, there's a bunch, everybody's working on drugs. So here's the bottom line. They're cancer drugs, but half of them cause cardiotoxicity. So what's the best thing to do? In the old school, the best thing to do was keep it a secret. And so if J&J was developing one and they failed, they didn't want to tell Millennium because then Millennium would have a leg up on them. J&J just spent $20 million on a failed trial. Why would you want to tell them? The new way of thinking is, hey, there's 500 pieces of the network here, and there are the tyrosine kinase inhibitors. There's like over 200 of them. We better share our data pre-competitively so we're all kind of going to the right answer because we don't have enough money to play the slot machine. And you needed something to actually achieve this. That became tranSMART. The idea was you could get tranSMART to do this if you spun it off in the. And then the other thing is, once J&J got their problem solved to their satisfaction, they're saying, we don't want to pay for this anymore. It's too expensive. We are in the pharmaceutical discovery business. We're not in the IT business. Spin it off. Well, they did. And then we picked it up. Who's we? Well, the Europeans were first to the party. They were, why? Because they had this huge program called the IMI, the Innovative Medicines Initiative, IMI, okay? And the deal was, it was big vision across the entire European Union. There was 1 billion euros over here, cash money from the European Union, and there was 1 billion euros from the pharmaceutical as cost share. And so there's a valley of death. So what the European Union says, we will limit the valley of death by forcing the academic researchers to work with the pharmaceutical companies by, putting in joint proposals, and if they're good, we'll pay the academics one-to-one cost share on a $2 billion program basis, funding 35 clinical and translational research studies in partnership with pharma. Then what happened? They needed a data sharing and analytic platform, and they picked TransMark. And then they dumped 50 million euros into it. Right now, we tried to figure this out at the July meeting. There's approximately $100 million of investment in TransMark right now that we're steering in the TransMark Foundation. That is a solid number, probably more. Half of it, way more than half, is in Europe, largely with the ETRIX initiative and the trait initiative, CTMM, and they're using it all in Holland. All the Holland academic medical centers are using it. There they are there. I got another slide on those. They're fun to work, those guys. It's fun. We had a fun meeting in Amsterdam over there, you can imagine. There's us, little dots. So Europe is throwing, Europe is throwing a lot more money. Okay, so the CTSA is about 600 million or so a year, but there's where the dots are. But when it comes to informatics, they're not really doing much. No central investment, no central plan, no central ideas. This is why the White House guys are saying, gee, can't you help us fix that? Europe's eating our... The irony of all ironies was we're transferring our code base that we paid. You paid like 25 million for the I2B2 code base, and then it's in the open source, and then you shipped it over to Europe and a bunch of companies, and then you kill the I2B2 side. Think about it. Crazy. So our center, I2B2 and NCBO, the National Center for Biomedical Ontologies, have created a lot of good stuff that are going, and others have too, like the imaging NAMIT and so on. But those are really going into iTransMart in a big way. So that's $60+ million of technology TransMart into the open source. And when I went to the NIH, and Jim was with me, to give kind of the closeout on NCIBI when they were closing down the NCBCs, I chaired the, what do we do next panel with the other PIs. And I remember Russ Altman looking at me saying, you got to talk. Remember that, Jim? It's like they said we were the successful ones because everybody else was just laying down and dying. No, they're not writing any checks for anybody. Public-private partnership. EU, the pharma companies, private, the government, public. Our work got us here. Here's some examples. This is a guy named Jeff Manley. This is coming from a place called One Mind for Research. It was set up to look at traumatic brain injury and post-traumatic stress disorder for veterans coming back from the military. They bought the whole vision, hook, line, and sinker, and they're using TransMark for everything in their world. And they're setting up studies. NIH just gave them, about 20 million for this track TBI study, and then philanthropy threw in another 20 million. So it's a TBI study that's on the order of, ADNI, the Alzheimer's Disease Network Initiative. TransMark is, here's the people underneath, public-private partnership. Here's their data environment, raw data, information, knowledge. They've got us down here, kind of their knowledge repository portal. Notice they got a lot of other stuff. But you'll see in a minute how this works. Okay, here's some output the preliminary data that funded CHDI, showing the I2B2 front end. We have several front ends coming up now, but they're still using the old I2B2.1. We've got a bunch of stuff coming from a number of pharmaceutical companies that are going to make this front end really cool. Here's the kind of data analysis, data pulls from the I2B2 into analytics. They do have some molecular biomarkers, largely in the image space. There's something called CHDI. The CHDI is a very interesting outfit. It has one donor, anonymous. They have a research budget of $160 million a year. If they need more, they call the anonymous donor through some middleman. I met the guy at some fancy room in New York City. It's a virtual pharma company, basically. It has 600 researchers. They haven't totally implemented tranSMART yet, but they're certainly looking at it. At home here, Chuck Barant Center, we're just gearing up and going to put that underneath it. Matthias has got a very interesting situation because he has 8 pharma companies that want to work with them that are using tranSMART in Europe, so they are very interested. All right, now, the tranSMART roadmap. I'll go through this for a few minutes, and I'll go through the foundation, and then I'll be done. That's what we want. We've got a big go live on 1.1 version coming up on September 15th. You know, one of the problems, Frank knows this well, in the old tranSMART, you need 3 guys to set it up and to make it run. We have a thing now, Frank, where you push a button and it loads. He said he wanted it. He was Frank got into tranSMART before anybody else. He was in on it on the earliest days and brought it to the Cancer Center for Steve Gruber's colorectal project. It was here. You were the guy that way before I even knew about it. You came and told me about it. I didn't even know about it. So, you know, so we've got a roadmap, right? Software content community. We don't want it to look like that, but, you know, if you're not careful, and I'll explain to you exactly why here in a minute. So here's our roadmap that we presented to our members and founders and sponsors in July. It's kind of 2 roadmaps. We're here now. We are releasing this on September 15th. Then we've got a fast follow here. I'll give you the details in a minute. This will be released long before BioIT World in April. And then ... But we're really, this is called the promised land. This is where we want to go, and the quicker we get there, the better off we are for several reasons. All mainly having to do with who really owns the code base with the right license and what's the architecture. And so, you know, we're, you know, so there's a plan. All right, here's a bit of the problem. I was going to stick this in. This is problem is also, you might know, who's that guy, Terry? That's the developers. That was called a developers and users meeting. That was in Amsterdam. So think about this. I2B2 had 4 developers and no committers other than Harvard guys. They said we could commit. We call a meeting. We got 80 developers. We're not. I do pay Terry. There's a couple people. They're all being paid by somebody, but not me, not us. So you know, so I had to give the keynote and tell them what to do, and I did it like from my house at 3 in the morning through a webinar, because you know the way they had it scheduled in Amsterdam, right? It was like daylight there, but it was in the middle of the night at my place. Worked actually pretty good. It's amazing what you can do with video. That's what I told them. I said, hey guys, somewhere I said, I don't want anybody looking at 1.2 and I don't want any conversations about 2.0. All right, and I know you guys hate bug fixing and testing. All you want to do is code and move on. Sorry. We got to release some damn good code with some decent documentation. So focus. You want to help? Join some working groups. No, they did. It was pretty amazing. Notice Kevin and Terry and you know my tranSMART team. Where are they? They're not here. They're working on the release. They know these stories. You know, in the early days, this came from the February Ann Arbor meeting. I copied it right out of this book, and this is a direct copy off this book. Linux, just copy it. It's a meritocracy. The guy in the front of the line is the guy they all respect. He's Linus Torvald. You can't control that. You just find him. So we've got this guy, his name's Kees Vanderboom. He's Linus Torvald. He's an Amsterdam guy that works for some place called The Hive. He's incredible. I says, we need to get I2B2, it's the spaghetti farm underneath there, make it modular so in 2.0, it's a service in and out of an API, application programmer interface. You know, it's got to happen. You know, we figured, what do I know? We figured it was take a year and $1 million, right? He sent us an email in 3 days and said it was done. Belief, trust, and you know, you can't fund that. You've got to bring together a community and get them excited about something and get them to go. That's how Linux was done. That's how Apache was done. That's how, you know, we had all these phone calls, you know, and these guys are beating me over the head. Hey, you don't know anything about it. Check out Apache. Check out Mozilla. Check out Linux. Give me a call. Talk to this attorney. Because the way you're doing it is wrong. This is the way you got to do it. If you want code that people are going to use all over the world, it has a prayer. I'm not saying that you guys can't sit in the lab and code and create science. That's absurd. But if you want to transfer it to something that people can use, now we have Athey. Everybody uses it. We have a big server there. It works pretty good. There's always exceptions to the rule. But you know what we need is people that create modules and then contribute modules. So you might ask, how does that work? This is how it works. So you can go on a GitHub. How many people know GitHub? A lot, fair amount. That's cool. Go on to GitHub, type tranSMART, and look, you can see all the code out there. Okay, we got the branch. The main branch is the 1.0, and in 2 days it'll be 1.1. You can do whatever you want with your own instance. Create on the branch, and then we've got the techies around the world, and we'll figure out, based on what the users say, what goes on to the 1.3. Based on what's on the branch, based on what people want, and based on how that code looks with our code. And, you know, every time we redo it, we refactor it. And this is a very tricky thing that I don't know yet, because you have Linus Torvald and everything else over there. So really, there's this huge discussion. You send it to a third party and recode the whole thing on the branch. It's been back and forth. We don't want to piss off our developers, but at the same token, we need high quality code. And Linux outsources. Every time you move from a branch from a branch on GitHub to the main branch, you recode with pros. I guess that I would say that that's, if I would have had to guess, that's what we're going to do. So then, you know, so we went through all the stuff. So we have it all laid out. What's in what, box, when. Here's what the 1.1 looks like. It's ugly. But, you know, we do have I2B2 in a box at least. You know, it will be released. Here's the team. Notice, you know, I sent Terry to London, and Terry Weymouth is our chief programmer. I sent him to London to the London Etrix meeting. You know, in February, they voted him as Linus Torvald. You know, he did it on his own. I mean, I didn't give him any PowerPoints. Imperial College London, which is the core work package 2 lead for Etrix. Luxembourg University is core package 4, and AstraZeneca and UMich conchoed the 1.1 release, which really, and that's what's in it. The big bugaboo was moving from Oracle to Postgres. How could it be open source with Oracle? It was a historical accident that I2B2 was built on an Oracle. Postgres in 2005, when I2B2 started, didn't scale to 1 million plus rows. That was, you never want to do that. Releasing code is like, now you get into a business. That's why I'm going to start talking about the foundation in a minute. This is not academic. So this is the trouble. Here's the big, if you boil it down, it's simple, actually. What should the NIH fund and what should be on the outside in some kind of other vehicle? You know, and the problem is that all this activity is needed for academics, but it's not academic. Writing documentation for code and supporting the code is not an academic enterprise. So how much of it should we pay for? How much should the government pay for? How much? It's a real problem. It's a real problem. It's right on the edge. And so what happened is in this transition from cyber infrastructure, it just went through the edge, and now it's on the other side of the edge. And we are struggling to figure out, so NIH is saying, I was telling at the Dean's meeting yesterday, it's like we better start planning because all the reports in the NIH are saying that, like, they're not going to pay people to just do grants all day long, that we have to, like, pay our own guys part of the time. Maybe the NIH will fund us 50% of the time. NIH is not going to build infrastructure for you. You have to build your own infrastructure. So there's a huge financial shift going on, and this is all part of it. We are right on the bleeding edge of this thing, believe me. And that's what gets us into these big time meetings all over the world, because this is the way it's going. Okay, 1.2. Here's, I got the 1.2 release pretty much. Notice I got UMISH still on the list. We're going to transfer all the NCIBI into 1.2, and that's got the site escape modules. That'll be good, and all the knowledge bases. I wanted to show you this. You know, this just kind of came through the email. This is one thing about running something like this. Be prepared for the unexpected. It's like this Hive guy, the real Thorvald, Kays. He's the real guy. Gary's great. Kays is the guy. You know, so Holland sends you a map. Holland says, hey, boss, we're doing pretty good. Here's our progress report. They don't report to me. Here's what we're doing. We're putting all this in. Here's our plan. We're going to upgrade. We're going to not only have Open Clinic integrated with TransMark. Here it is. We're releasing the bugs. We're working on the bugs because they're running all of Holland on it. You see, that one of the themes here is that Europe somehow has figured out how to do this, and we haven't. And we are paying catch up. And part of the thing is, from an economic, portfolio analysis look, we're not doing this right here in the United States of America. And the problem is, you get on the phone with these pharmaceutical executives, you say, hey, I need $1 million, for this, a foundation. I need $10 million over 3 years to keep the lights on. They're saying, Brian, we already gave you, $2 million over in Europe. What the hell? You didn't give it to us. So it took a while to figure out. You got $100 million being invested in this. Give me 10% of it over 3 years, $10 million, and we'll keep the code base from turning into spaghetti. And that's going to work. But it's just like what happened with Netscape. And when it went into Mozilla, that's what's happening. So all this software, so whether it's Galaxy for bioinformatics or anything, it's all going to happen this way. The NIH and NSF and all of them are pulling out of the game. All right, I think you believe me. We've done our homework. There's 2.0, the way it looks more reasonable. I fought with EK, who made this. EK Gao is an incredible guy. He's the PI over in London. He is a cool guy. We'll have him. He's a lot of fun to be around. He's created a lot of cool companies and computer science professor. So there's your data, there's your middleware, there's the analytic app farm, there's the workflow engine, there's the presentation, visualization, applications layer, standard plug and play APIs, CDISC. We're paying CDISC a lot of money in Europe. It'll work. Quicker we get there, the better. So we got plans. I'm going to rush through so I can do a little bit on the foundation. I do want to talk about content a little. I'm going to do it this way because you're going to hear more and more and more about this. We're going to put a big proposal in after the BD2K on the cancer cloud pilot projects. Pilot is a misnomer, and this takes away some of the stuff I was saying. Of course, NCI put $350 million into CA-BIG. That was the biggest disaster. There's 2 other bigger disasters in government, the IRS and the FBI information systems. The Intel guys won't tell you how much they spent. But NIH spent $350 million north on CA-BIG. It failed. It was a top-down dinosaur. And so they're asking for proposals and partnerships for cancer data and processing clouds. Now, they're going to do 3 of them at $5 to $6 million apiece. Look at the difference in the amount of resource. So we're going after one of them with Chicago and the Open Cloud Consortium. Here's some, TCGA. There's 20 TCGA data sets. 1,000 knowns, 1,000 affected, 1,000 controls. You want to be able to do some genomic analysis on that. You have to go through a process that takes up to a year. Europeans can hardly get into it. We've got a way to authenticate into it. Best, you still have to have the permissions. It is a national disaster. And in fact, they cut the budget to CCGA because of it. Here's the data. You can't get access to the data unless you have all these permissions. That's being worked through, and we've aggregated, with Chicago as the lead, the 4 petabytes or so of data that everybody needs on a cloud. There's 2 clouds. There's the restricted access cloud that would include PBCAP and TCGA and those kind of things, and then there's the open access NCBI resources, 85%, 1,000 genomes, whatever. It's all in there. It's all annotated. It's all curated. God knows where Bob Grossman got the money. University of Chicago gave him a lot of it. This is in the content layer. So the idea is you have the biologist there. You have sequencing reads coming in, either from Bob's Core or from Complete Genomics or BGI. I don't even want to go in there. You have 2 kinds of clouds. TransMART sits as the middleware and application layer on the data layer. That's what we're building. That's what we're proposing the NCI. But, anybody who writes a proposal better build it before you send in the proposal. So we're building it now. Because our researchers need access to this data, and we're not going to build a 4 petabyte plus farm here at the University of Michigan to store the same data that's sitting in Chicago. We will need to upgrade the optical network link. But we bought, as you recall, some of you who heard my talk 15 years ago, we bought, all the optical fiber, along the railroad tracks all the way to Chicago for 20 years. Paul Courant bought it for $1 million. We have the fiber. We have the link to the Chicago point of presence, right down to State Street, right through the old Internet 2 headquarters, right, and then we put fiber right up the street. So everybody ought to be able to look at this data in near real time. That infrastructure was built. And so here's a block diagram. We're around in this block diagram. We are there. There's TransMark. TransMark's up in here. We're up in there. We're adding this into the Chicago Open Cloud Consortium right now. And then we got Ryan. We got some users already. We want to put this in through the University of Michigan and give everybody access. So tomorrow I got a meeting with Eric Nicholson to talk about this. And, I've been talking to the deans and so on about this. This is like partnering. So if we partner with Chicago, we partner with Indiana, which has got all this infrastructure on the floor and huge computing. Maybe we can make up for some of our deficits here at Michigan and stay in the game. That is the basic plan. Notice I said we had deficits. Licensing, big problem. I'm going to quit soon. I'm just going to take you through the foundation. Licensing is huge. We do not have the best license in the world for TransMark code right now. It's GPL version 3. Anybody knows anything about open source license and start running for the doors. Why? It's the poison pill of open source license, which means that if you put it into your code, everybody owns the code next to it. So we are talking to lawyers and spending money and racing towards 2.0. And J&J has been the holdup. So there's nothing better than sticking British Telecom and the IBM Corporation on them. We'll own the code soon. We own the documentation. And we figured out a way to own all the 1.1 code. It's just, so why did J&J make a GPL version 3 license? Here's why. Because they didn't want to spin the code off into the open source and then have some company, Oracle, pick it up the next morning and sell it back to them. That's exactly why. It flowed out. It took me a year to figure it out. I didn't know anything about it. It's amazing how much you learn. We got all the wikis. You can get them right through the... All right, so here's a list of folks that are running this code all across the country. Notice I put you on there, Frank, as an early adopter. This is just a tiny little list. And these do not include all the projects funded in Europe on the ETRICS and the CTMM. All right, TransMark Foundation. We realized that we were spinning off a company, so we needed to spin it up. So we held a planning meeting. There's Terry. There's Gil, the back of Gil's head. There's a bunch of people. It was a very interesting affair. We didn't pay anybody's way. It was blizzards on the East Coast. The traffic, everything was terrible. We invited a bunch of people from Europe. There was about 45 people that came, and everybody showed up. And it was really an amazing meeting, and I'll tell you, it was stressful. Because, you know, it's like herding the cats. And I was running around from one room to the next, trying to keep everybody in line, and you know what? It worked. And because everybody kind of was committed to these, was motivated by all this high-level stuff, it made sense. And the basic idea is that if I here at the University of Michigan, even with like big resources that you can get from Dean and the EVP and all this, if we think we're going to code up the future of how we're going to do this omics integration with a biorepository, EHR and everything, we are sadly mistaken. This is a world-class problem. It needs a team. The team is bigger than one place, and everybody in the room who flew in knew it. And it wasn't just, you know, academics. In fact, we had a few academics, some from Europe, some from America. It was companies. Perkin-Elmer, Thomson Reuters. Why? Thomson Reuters. We went to the Thomson Reuters office in Boston. He says, oh, I got good news. We got 12 tranSMART instances in Japan. You got it all through Japan. It's going through Japan now. Why? So what do they care? Because they're selling curation services on top of it. So, you know, when companies are making money with the code base, they're willing to invest in improvement of the code base. I mean, this is just starting, man. This is going to go like Linux. You know, the buzzword is ecosystem. There's your ecosystem. We have real players in all those. Food and Drug Administration has evaluated several instances of tranSMART and are very committed to sticking it in for lots of different things, as an example. There are many companies, Deloitte, Recombinant, 5AM Solutions, IDBS, Perkin-Elmer, Thomson Reuters, that are making money out of doing tranSMART instances everywhere. This is the thing that got out of the box. So I'm soon going to be giving up my CEO-ship. I'm the founder. We got a vision and a mission. You can imagine Gil, who has been serving as chairman of the board with his good friend Lee Hood. So they were pounding me on this one at this one meeting when we got it. We have goals. And the goal is to, you know, build and sustain this platform and get everybody to contribute and keep the developers happy and keep the users happy and, you know, get it out there. We have things that we do in the foundation to make the thing go. There's our team. You know, we're all working real hard. We have a board of directors that will increase to 15 members, 10 from industry, 3 from academics, 1 at-large board member, and 1 from, you know, a information, some kind of John Wilbanks, you know, the guru of you know, the old Creative Commons guy. Keith Elliston, who's now our Chief Science Officer, is brilliant. I vote for him to be the CEO. And sorry I went over, but that's my story. Invite me back next term and I'll talk some science. But this is what we had to do to stay in the game here at Michigan. This is the best shot that I could come up with. And I'm happy to tell you that if I dropped over tomorrow, tranSMART would go on. Thank you. Listen, there's some music. I quit talking to this. How did that happen? It's probably playing all over.
So Brian, number one, let me congratulate you because this has come a long way from when I first saw it a couple years ago.
Thank you.
And you know, this looks very impressive as a potential platform. I'd say that our practical experience with this has, you know, been fraught with some peril. Obviously, we had a very early
You
version.
got in
Right.
probably too early.
Too early, perhaps,
We
right?
needed recombinant more.
But at any rate, one of so we've encountered a number of issues with this. One of the problems, though, is the security model, and I'm wondering.
Big issue.
Yeah.
Big issue.
And I'm wondering if you could say a few words about that.
Yeah, that's really a toughie. That's a good question, Fred. This has to do with the fact that you're dealing with data that could be HIPAA, HIPAA or the international equivalents. It all has to do with how good your de-identifiers and anonymizers are, and if you're going that approach. And I think that's a huge. I'm surprised it hasn't come up more, to be honest with you. And there's another question that goes right in with this one, and it's like auditing and validation, because you got all these pharma companies. So the conversation that I've been having with my exec team lately is, what we need to do, and we got a meeting in something called PRISME, which is 20 pharma companies, R&D leads, and biotechs. It was in Paris. We were there. Now we're in Boston. The PRISME meeting's next week. And our pitch there, at least to some of us, it's related to this a little bit, is don't you want to pay into this foundation enough so that we can get the code base ISO certified so that you can audit it? Because if I were a pharma company, I was sitting in the boardroom over in Pfizer Cambridge, and the director of the whole thing, this guy Matteo Tamamasa, used to be, Jim knew him, and the guys he was at Pfizer years ago. I was kind of saying, hey man, when are we going to get to this? So I would say that we don't have those answers quite yet. I think the way that we're doing it now, not to totally evade the question, is that in reality, most of the tranSMART instances exist behind the firewalls in the pharma companies in our restricted access instances and not open access clouds. And we are opening up an open access cloud by British Telecom is putting it in Europe on their cloud infrastructure for the European community, and it's going to be an open access cloud with fully de-identified records from the National Health Service, 60 million of them, longitudinal records. So I bet you this is going to come up more and more. I think that's how we've gotten around it, but we've got to push that into. So I'll throw that over to the architecture working group and ask them to give us a report. I really thank you for asking that question.
Much of this can be seen as work to build the infrastructure required to improve productivity, as in the pharmaceutical industry. There's another side of this, and that's clinical trial designs. We're burdened with designs that go back to 1948 that put the effects of genetic differences in the error term of statistical models and so on. Is there anything being done in conjunction with tranSMART to solve these fundamental clinical trial design problems, for example?
Well, I'm sure you picked up on it, Curtis, that I did mention this whole stratification aspect in that one box where those people were a different color. And, I think it should be, I think you, of all people, would recognize that pharma, which is a big driver and the biggest user of this tranSMART platform, has recognized that averaging everything out doesn't work, and that there needs to be stratification. To get to complete individual stratification, as you're proposing, might be a road too far for a lot of them. But, it makes total sense, given everything we've learned from haplotype, and in my area of pharmacogenomics, psychiatric pharmacogenomics, if you need to now stratify on ethnicity, take some examples, simple examples in pharmacogenomics, metabolism of codeine and morphine. Well, African Americans don't do that very well. So if you could even stratify on, ethnicities and on age, like old people, we're getting there, take a lot more pills than younger people, so the polypharmacy effects and so on. So if you're doing it for pharmacogenomic purposes or clinical research purposes, stratification is absolutely critical. Several of the folks are talking. There will be a working group on this at the Sanofi-hosted meeting in Paris in November. People are talking about it. People are doing something about it. I attended the gave us a presentation at the World Pharmacogenomics Conference in San Francisco in April, and everybody was talking about it. So they're catching up with you guys. And I'd be happy to give you more details on it. Yeah, it's a good question. Dennis. Oh yeah, I mean, actually, that's solving itself. That's solving itself. I've already mentioned this. You know, there are companies out there, Deloitte by Recombinant, which built the first tranSMART instance for J&J when they were just recombinant data. You know, the IDBS guys, which E.K. Gao created as InfoSense and then spun off, and then it became IDBS. And they supply mostly electronic laboratory notebooks into pharma, you know, especially in Europe. You know, Thomson Reuters, huge company. They bought up Jingo and other companies already. Thomson Reuters makes a lot of money providing value-added services on top of tranSMART and often code up modules. The pharma companies. That's just kind of happening. But, you know, what we say is, hey, you put code out there and you're using the code, the rules of the road are you got to put it out on the GitHub. And so when we had at BioIT World, Thomson Reuters hosted a community meeting over there. We had about 85 people show up. And, you know, and then Janssen, okay, Millennium, GSK, and J&J stood up there, and Sanofi, Sherry Cow at Sanofi stood up there and showed all the improvements to the front end that they had developed that made our tranSMART look like garbage. And then, and that's all out in the open source on the branch. And then we decided, and then actually Pfizer had a meeting, called a meeting in Boston, and passed the hat and said, here, you know, foundation, write an RFA, pick the best guys to do it, we'll fund it, and we'll pay for 1.2. So that's happening. So that's well on the way, well on the way. It's no ecosystem if people aren't making money. And that's the thing that's been amazing about it. The government, now, you see, and it's also amazing that, you know, from the geopolitical perspective, that, you know, Europe puts in all this money and it, you know, it spreads. You know, the initial capitalization can come from anywhere, but then it can spread, as it's doing in this case. Now, I looked into the sustainability for, we went through a lot of deep dive on the sustainability models for the Linux Foundation. It turns out that the Linux Foundation members pay, you might know this, to sit on the board of the Linux Foundation, you're paying $500,000 a year. And they've got, you know, 15 board members. And, you know, Linux Foundation wants something done, they just pick up the phone. Now, when we had our member sponsor meeting, you know, we got 5 or 6 pharma companies willing to do 100,000. We got a number of other ones willing to do 50,000. We got some not-for-profits. And then we got some, so, you know, and memberships, we probably got, you know, 750 or $1 million. But, you know, what we were told by the companies, if we could come up with some kind of deliverable, like if you could deliver 1.2 by a certain day, we would pay you for that. Put a price on it. Put a value, put a 20% markup on it, and take that away. And so those guys came up with the ideas and gave them to us. So, so is the tranSMART Foundation totally financially sustainable right now? No. Did I have to put some money in it, or Umish money, to get it off the ground? Yeah. But is it going to take off and be sustainable? Absolutely.
My turn?
Good.
Hey, how you doing? I guess I can just talk. I'm pretty loud. Oh, you prefer? Oh, I was recording. So, I'm watching this. I see there's a lot of things going into tranSMART, but I'm still kind of confused on what exactly it's trying to be. Do you have maybe an example of a user that's used it and obtained something they wouldn't have been able to do without tranSMART?
Well, I showed one example. There are many. I did show the track. You know, it's in fact, we're collecting up a lot more of those so-called use case examples, and there are many of them out there. I did show the track TBI example. And I stripped out many other examples. Right now in ETRIX, there are currently 8 of the 35 projects are up and running on the platform. There's a big 35 site cancer project up there, it's called IU Biopred, et cetera. I could give a whole talk on that, and I can just say, and I put it in my little abstract, but didn't get to it. Johns Hopkins University is planning a very large demonstration of tranSMART capability within one of their units at Hopkins that I'm involved with right now pretty closely, and a number of you Mich guys are going to be paid to work on it. So there are many examples that are emerging. There's some neat asthma studies that are being presented at the PRISME meeting next week by a guy from Paris who's working with Zach Kahani. So forgive me, I think it's a very good question. I just didn't start putting the talk together until 12:15. I was looking for a few easy ones, but they were all in PDF. All right. Okay, Dan, I got off the hook. Thank you for coming. Oh, that's fine.